Okay, now we're going to take a look at solving the systems of equations by substitution. So this is the second method for solving a systems of equations. We're going to start with this example here. So the first step is to solve one of the equations for one of the variables. So you either need to have x equals something or y equals something. Now if you look at the equations we've been given, we've been fortunate enough that one of the two is already solved for y. I'm going to label these A and B just so it's easy to talk about them. So my B equation is already solved for y. That step has been done for me, so that's a little bit less work, which I'm grateful for. The second step for substitution is to substitute the solved equation into the second one. So I first started with equation B, so now I'm going to go to equation A. That equation is negative 2x minus 3y equals negative 7. Since I solved for y in the first one, I'm going to substitute for y in the second. So negative 2x minus 3, and then instead of y, I'm going to have whatever y equals in the other equation. So in this case, I have 6x minus 11. So 6x minus 11 gets substituted in for y. Now that I have this, my equation A is all in terms of x. So it started with x and y, but now I just have x. So now that it's only in one variable, I can solve for that one variable. So we're going to distribute that negative 3 and start solving for x. I'm going to combine my like terms here and get negative 20x plus 33 equals negative 7. Subtract 33 from both sides, and we will get negative 20x is equal to negative 40. Divide by negative 20 on both sides, and we get x equals 2, a positive 2. Okay. So remember, when you're solving a system of equations, you're looking for the point where these two lines intersect. So that means my answer needs to be an ordered pair. Ordered pairs are always x, y. Well, I just found my x value. I found that x equals 2. Now that I know that x equals 2, I'm looking for this y value. So I need to know, what does y equal when x is 2? So for that, you're going to go back to that first equation that we worked with, equation B, and I know that y equals this, 6x minus 11. And now I know that x is 2. So your third step is to go back to equation B, or whichever one was solved for a variable to begin with. And I'm going to substitute in the value that I found, which was 2 for x. So I have y equals 6 times 2 minus 11. 6 times 2 is 12. 12 minus 11 is 1. So when x is 2, y is 1, which means my answer and my ordered pair is going to be 2, 1. We'll take a look at another example. I'm going to follow the same steps. So the first step is to solve one of the equations for one of the variables. So again, I need either x equals something or y equals something. Now looking at my two equations, neither of them have been given to me as x equals something or y equals. So we're actually going to have to do that first step and solve one of the equations. When you do this, you want to stop and look and ask yourself what would be really easy to solve for. And I noticed that this x here is all by itself. And in order to solve for x, all I have to do is move this minus 2y over. So that would be a really simple thing to do. So that means I'm going to start with my equation A, and I'm going to choose to solve for x. You can choose to solve for another variable. It does not mean that you will be wrong. It just means that you might have to deal with some not so nice numbers along the way. So when I solve, I'll get x equals 2y plus 11. So now that I picked equation A and I solved for one of the variables, I'm going to go to the other equation, equation B, which in this case is negative 7x minus 2y equals negative 13. And since I solved for x in the first equation, I'm going to substitute in for x in the second equation. So So I'm going to have negative 7, and then instead of x, I have this expression here, 2y plus 11. And then comes the rest of the equation, minus 2y equals negative 13. Now I have everything in terms of y, so I can solve for y. So the first step to do that would be distributing this negative 7. So I have negative 14y minus 77 minus 2y equals negative 13. I'm going to combine those like terms. I have negative 16y minus 77 equals negative 13. So now I'm going to add 77 to both sides. So I have 77 minus 13. That's 64. And I'm going to divide both sides by negative 16. And I end up with y equals negative 4. So that was a lot of work, but what I just did was found that for my solution, y is negative 4. So remember, we're looking for an ordered pair. So this means for my ordered pair, the y value is negative 4. I found the y value. Now I need to know what is x when y is negative 4. So I need to know what x equals, but I already have x equals 2y plus 11. So I'm going to use my first equation again. So I'm going to have my equation A, x equals 2y plus 11. And now that I know y is negative 4, I'm going to substitute in negative 4 for y. So 2 times negative 4 is negative 8. Negative 8 plus 11 is positive 3. So that means the x value of my solution is 3. So the solution to this system of equations is the ordered pair 3, negative 4. We're going to do one more. This one, I believe, should be plus. We're going to pretend that this is a plus sign. So we have, our first step is to solve for one of the variables. So you have to look and see what's going to be really simple to solve for. I'm noticing that this second equation, if I solve for x, I'll have to divide by 3. These aren't divisible by 3. If I solve for y, I'm going to have to divide by 2, and the other numbers aren't divisible by 2. So that kind of rules out solving for that equation. But when I look at the top equation, my equation A, I notice if I try to solve for x, I'm going to have to divide everything by 4. And 16 and 12 are divisible by 4, so that means I would have some nice numbers to work with. So I'm going to choose to solve equation A for x. So I'm going to subtract 16y from both sides. Get negative 4x equals negative 16y minus 12. Divide everything by negative 4. We get x equals 4y plus 3. Now that I've done that, I'm going to go to the other equation. Negative 3x plus 2y equals 1. And since we solved for x, we have to substitute in for x. I'm going to have negative 3 times whatever x equaled in the first equation, 4y plus 3, plus 2y equals 1. So, first step, distribute. So I have a negative 12y minus 9 plus 2y equals 1. I'm going to combine my like terms. I get negative 10y minus 9 equals 1. Add 9 to both sides. And I get negative 10y equals 10. Divide by negative 10. And we find that y equals negative 1. So once again, I found half of my ordered pair. And that half is what the y value is. So I know that it's something negative 1. So I need to find what x is when y is negative 1. For that, I'm going to start with that first equation again that I've solved for x. So I found that x equaled 4y plus 3. So I'm going to substitute in my y value now. y is negative 1. 4 times negative 1 is negative 4. Negative 4 plus 3 is negative 1. So it turns out that the solution to this systems of equation is negative 1, negative 1. And that's how you solve a system of equations by substitution.